My name is Ashish. Today I am here to showcase and demonstrate my AI project. The project that I have chosen is heart attack prediction. Here we use various features so that we can predict an individual will likely suffer or not suffer from heart attack in near future. My project starts from the introduction where we introduce what heart attack is and how does the heart attacks occur and some of the symptoms of it. Then we import a basic data set which I found on the Kaggle. It's a good data set and many people have analyzed on those data set. uh, as you can see from the dataset, we have 303 and 14 columns. But before that, let's analyze the variables that is given by this dataset. As you can see, there are various definitions of the dataset. Like we have ASX, Exang, CACP, and and what they do are they are usually represented in numerical form, and what their means is like for the age, the age it's in the years. For the sex, if that is one, then it's male, and if that is zero, and it's a female. For the CP, it means that it's a chest pain type, and for the one, it's typical agnosia, and so on. For and after getting the data, as you can see, we have like 303 rows and 14 columns, and all the variables in data sets are like integers or float, and also there is no missing values, as you can see. um, then there comes a step for preparing exploratory data analysis. Here we examine the missing values and examine the unique values, like we did. Like we first examine the missing values, and then we examine the unique values. And what we get from that is there are like two types of variables that are currently in that data set. There are like numerical variable, and there are other type of variable that is categorical variable. And on the numerical variable we have like age, tribals, coal, and on the categorical variable we have like sex, CP, and so on. Then we separate those variables for numerical and categorical, as you can see, and we examine those variables where we can get various stats of that features of the features or of the columns. Like for the is strips calls, we have like counts. Its mean is standard deviation, its median is 25%, and so on. Now we analyze those data and develop a different graphs to visualize the data using these plots. And all my analysis is written on the notebook. As you can see, this is the plot of the age, and so on. Now comes the step of exploratory data analysis. Before we prepare for the exploratory data analysis, now the step is the exploratory data analysis. And we distribute this section into two parts. And the first section is the univariate analysis, and the second section is the bivariate analysis. On univariate analysis, we analyze using this plot for numerical variables and using pairs pie chart for categorical variable. So in a bivariate analysis, or for sorry for also in a univariate analysis, we examine the missing data according to the analysis. As you can see from here, first we analyze using this plot for the numerical variable, and then we use pie chart for the categorical variable. And I have wrote all my analysis in this section. Then we examine the missing data according to the analyzed result, as you can see from here. Now the section of now the subsection of the EDA is another is the bivariate analysis, where we use different other plots like facet grid, count plot, pair plot, swarm plot, or box plot, and heat map. For like for the numerical variable, what we did was we targeted the variable with a numerical that has a numerical data and analyzed using the face grid, as you can see from here. And for the categorical also, we targeted those variable relative variable and analyzed using a count plot, like we did from here. Then in addition, we examine the numerical variable among themselves using like pair plot. As you can see from here. And why we use pair product is it allows us to see both distribution of single variable and relationship between two variables. After that, we scale the feature with robust scaler, which is a method from the scikit-learn package, as you can see from here. Then again, we perform some other plots to get to know more about the data, as you can see from here. It's a swarm plot, it's a box plot, and then the last we create a heat map to show the relation between different variable, like we created here. And we analyze each plots in our own sentence. Now the steps come for preparing the model. The first thing we did was we dropped the columns with low occurrence, or what I mean is we drop the columns with a low correlation. Then we visualize the outliers. After we visualize, we deal with that outliers like we did here. Like we first visualize the outliers and then we like deal with those outliers. Okay, then we did with all the outliers. Then we determine the distribution of the numerical variables. Like we use like transport method for it, as you can see from here. Then we transfer the operation on unsymmetrical data. On the other hand, we also applied one hot encoding to categorical variables so that it is more easily utilized by so it can be more easily utilized by an ML algorithms. Uh, then we scale the feature with a robust scaler that is robust to outliers data. It scales the feature by centering them around the medium and scaling them by IQR or interquartile range. It significantly impact the performance and coverage of our model. Finally, we separate our dataset into test and training set. Now we are ready for modeling. Now for modeling, it's the important step. And for modeling, we use four different algorithms: logical, regression, decision tree, algorithm, support vector algorithm, and random forest algorithm. It's a main and it's a crucial part as it decide whether our model is properly working or not. We start from the logical regression. I utilize logical regression with cross validation that access the model performance and robustness by splitting my data into multiple subsets, as you can see from here. And after doing that, my cross validated score is like 0.86, which is like the 86%. But before, like only when I did logical regression, it was 0.87, which is more better. Then the RUC curves and asymmetrics were employed so that the gauge uh, employed to gauge the model ability to distinguish between the classes, providing a comprehensive view of classification performance. And by doing a RUC curve and area under curve, we can get this result. Then in addition, we employ the hyperparameter optimization through a grid source CV to tune the model's hyperparameter, ensuring it was optimized for specific characteristics of my dataset. And the test accuracy after that was of 87%, which was more better. Then the next algorithm that we used was decision tree. Uh, I I used decision tree and like got and trained with an algorithm and got an accuracy of like 83% or 0.83, as you can see from here. But doing a cross validation, it still decreases my model accuracy. Then now support vectors comes in action and provide the accuracy of 0.87 as you can see from here, and it is the highest till now. Support vector is doing really well. Finally, on random forest algorithm, the test accuracy was 0.83 or 83%, but after cross validation, the accuracy got up to 0.89 or 89%, which is amazing. Again, we try to optimize using hyperparameter, and we got the result, and we somehow managed to get up to 0.90%. As you can see, the accuracy of the random forest of hyperparameter tuning is 0.90, which is great. Therefore, the conclusion comes here is, by using different algorithm, we come into conclusion that random forest gives the better result in this situation. That's it for my demonstration. Thank you.